Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and this is going to be an awesome video about parabolas, straight lines, and all of those wonderful, wonderful things that my matriculants love to answer. No, I'm joking. My matriculants struggle with these because there's a lot of difficult things that just kind of slips in. So it's very, very important, your analysis of a question. That's why this video is going to be a bit on the long side. I'm not exactly sure how long. Maybe it's going to be 25 to 30 minutes because I don't just want to answer the question. What I really, really, really want to do with you is analyze this question 7 from the DBE November 2021 Maths Paper 1. So let's start by, first of all, just getting the question on the screen. Now, they give me a graph f of x and they give me a lot of information. So I want you to take your time, read through this, try it yourself, and then I'll do the rest with you. So hit the pause button and go for it. Now, when we look at this specific sum, it is kind of easy, but I want you to be careful of just running headlong in it. So how do I analyze a question? Especially a big question like this that's worth 17 marks. That's more than 10% of your question paper. So please bear with me. I'm going to go back to basics. Let's start by the information given. First of all, they give you the graph of f of x. Now, f of x is a parabola. I can see that and they give it to me, okay? But if I'm given a parabola, I love to first of all multiply out the brackets because I know out of experience that the different forms have got different advantages. Like the first form where it's in brackets. Well, that's going to be easy if you want to get the x-intercept. But the second one is easy if you want to get it in standard form. Why would I want standard form? Because I can interpret more. So if I want to interpret more, first of all, A is 1. That means my graph is smiling. Perfect, that's a first analysis. Secondly, the negative 24 is the y-intercept. So I can automatically read that off. So this means that on my graph, I can write this in at G. Fantastic news for us. I can interpret more, but I'm not going to interpret more because then we start going into very murky waters with pluses and negatives, etc., etc. Things that's not really necessary. But let's continue reading the second sentence. The second sentence says that I've got an x-intercept, 2 of them actually, at B and D, which means y is 0. I've got the y-axis where the graph cuts the y-axis, so I've got x equal to 0 there. Also, the very important thing, that little bit of information that C is the turning point. So therefore, there's an axis of symmetry, which means the distance from B to my axis of symmetry is the same as from D to my axis of symmetry. Axis of symmetry is a very crucial thing in the exams. I've seen them ask it so many times and my students mess it up because they forget about it. Please don't. We are going to work with the axis of symmetry here, but only when we answer the question. Now let's go to the fourth sentence. The line AE has an angle of inclination. Boom, I know that I've got to use m equal to tan theta. But sir, that's paper 2 knowledge. Please, my students, my wonderful, intelligent students, listen up. They are going to ask 1 or 2 questions, sub-questions, in an exam which requires knowledge from a different paper. It's been happening the past 2-3 years, every single year. They ask, for instance, inclination in paper 1, but just 1 question. Or they ask you a sequence and series question in paper 2, or a sigma question in paper 2. It's usually very simple and straightforward, but you've just got to be aware of it. So you can't just get in the mode that I'm in paper 1 or I'm in paper 2, and therefore I'm not going to worry about the other paper's knowledge. Be careful. But let's continue. I've got a x-intercept at A where y must be 0, and a y-intercept at E where x must be 0. This is now a very important thing because we are going to use it a bit later on. 7 minutes, just interpretation. Now, I know you might look at this and go, but so I don't have 7 minutes. But it's not going to be 7 minutes. It might take you 3 minutes. But 3 minutes is worth it, matriculant. It's worth it because I've basically answered a lot of the questions, okay? It is important that you get all of your knowledge on the paper so that you don't miss anything. Now let's go to the actual questions. So before we get to the actual questions, I forgot to analyze my straight line because, okay, what I just wrote down there was my t is x comma fx, which just means it's a point on there. But let's quickly interpret my straight line. Y equal to mx plus c. Now, what do I know about m and c? Before I carry on to the actual questions, I know that the m value is positive because the graph is sloping upwards. I know that c is positive. Why? Because it cuts the y-intercept above the x-axis. Now, this is not so much as being crucial information. No, this is information that can be a checkpoint for you in the rest of the sums. Kind of just, am I doing the right thing? Am my answers making sense? That is very, very important. So let's go to the actual questions. Question 7.1. Write down the coordinates of B and D. Let's just quickly analyze what they are asking. They're first of all asking for coordinates. I know I need x and y. What do I know from the information? We know that y is 0 because they told me it is an x-intercept. And also from the graph, I can make a very calculated guess that it is the x-intercept. When I look at the x-intercept of that equation, I know I've got to make y 0. So that gives me x equal to -4 and x equal to 6. Always, my students, put the information down on the sketch. So if I've got -4 and 6 there, I've got it. But now I'm going to go to a next level before I carry on even to the rest of this question paper. If I've got the two x values, I can automatically get my axis of symmetry, that blue dotted line there. Why? Because it's exactly in the middle of my x-intercepts. So I can go and get the midpoint between them, which gives me x as being 1. This makes sense, for me at least, because 5 units to the right, you've got 6. 5 units to the left, you got -4. So therefore that x equal to 1 is the axis of symmetry. Awesome news, because it automatically gives me the x value of the turning point. And that is actually important in the next question. Calculate what? Coordinates again. But what makes C so special? It is the turning point. So if I look at the sketch, I can just say, oh, but wait, on the sketch, I've got x as being 1. But you guys, if you've watched a few of my videos, you will know I'm never content with just one option. So the second option that you need to know again how to use, actually there's 4 options, #just saying, okay? The second option you can do is y equal to x squared minus 2x minus 24, where then I use x equal to -b over 2a, and that leaves me with x equal to 1. But isn't there another alternative? Yes, there is, a very, very important one. Let me erase here. A very important one for me to use. Which one is that? dy over dx equal to 0. And this therefore tells me that 2x minus 2 must be 0, and therefore x is equal to 1. But that's exactly what I got from the sketch. Now, if you are a little bit unsure about the dy over dx and why is it 2x minus 2, please don't be afraid, because in our next videos coming up later for the exam prep, we are going to look at derivatives, calculus in a lot more detail. So if you are a bit unsure about it, stick with your grade 11 knowledge. Stick with axis of symmetry. It works perfectly. But let's erase this so that I can carry on with actually answering the whole question. Now, if I look at answering the question is coordinates, so I need a y value. So I'm going to substitute my x in and write down that answer for the examiner. C is 1, -25. So on my sketch, I know that I have 1, -25. But how can they ask this same question differently? Because I promise you, matriculants, whether it be in your prelim or your finals, teachers love to ask a turning point in a different way. Well, turning points could also be asked as give me the range of fx, or the minimum value of the graph of fx. That's exactly the same question, just with an added step or two. Okay? So here's the important thing. Whether they ask you range or minimum with a parabola, look out for your turning points. Now let's go to the sketch where I have written in everything I've got so far. At 7.3, oh my goodness, look at the question. Write down the range of f. Did they actually have to ask you 7.2? And the answer is no. They could just throw in the range. But how do I interpret range? For me, I always say, y is then from a minimum to a maximum, or from the lowest to the highest values. In my graph, the minimum in this graph is the turning point. The maximum, the highest y value, is infinity. Remember, this graph grows up forever. It doesn't stop, but its lowest point is at the turning point. So my minimum is at negative 25. Now, does it touch infinity? Never. But it does touch negative 25. So in other words, that must be a block, a square bracket. So my final answer is y is an element of negative 25 to infinity. Simple and as easy as this. But be careful, they didn't have to ask you 7.2 first. Now we're getting into the meaty questions. Oh, I love these questions, okay? So far, I don't think, or let me say, you shouldn't have had much problems answering this question. If you have, you have a bit of studying to do. Go and check out my videos on the Junior Techie online site or on YouTube. Check it out because I've done so many videos about how to approach parabolas and graphs and all of those questions. There's a lot more content available. But let's look now at where this becomes interesting. Question 7.4. Given that theta is 14,4 degrees, boom, I love it because automatically I'm seeing that m must be equal to tan of theta. My gradient is 1 over 4 because if I substitute the 14,04 into tan, I get 0.25, 0, and then it gives me some values. So it's very, very close to a quarter. And there I've answered 7.4.1. Easy as that. Now, this next bit is a favorite of mine. I love this. I love these questions. Now we look at the rest of the information given. Because I need that to calculate the coordinates of t. So what do they tell me? There's a few important things to calculate the coordinates of t. The first thing is that it is a tangent to f. So t has a tangent. That's important. Again, they are looking for coordinates. So the moment I read tangent, I know that the gradient has to work with derivatives. Finish and law. You've got to get that. Tangent leads me to derivatives. Why? Because the gradient at a point, the gradient of the tangent is the first order derivative. So I love to just write out, I've got these keywords like tangent that I look out for. They also tell me it is perpendicular. So I know m1 times by m2 must be negative 1. So in other words, the tangent's gradient times by the gradient of AE must be negative 1. So I'm going to look at that. But first of all, let's get an expression for the gradient of the tangent. Doing my derivative, I've got 2x minus 2. I got that on the previous slide as well. But now I need an actual value for the gradient. Why? Because of the question. The question says coordinates, so I need an x and a y. So let's go and find the gradient of my tangent by using the perpendicular lines. I know that the gradient of AE is a quarter, so I'm going to substitute that in. Now M2 is the gradient of the tangent. So I'm going to calculate the gradient of the tangent by multiplying by 4 on both sides. So M2 is equal to negative 4. But that means the gradient of my tangent is also negative 4. Or it is actually not also, it is negative 4, which means I can solve x. So I'm going to transpose the negative 2. I'm going to divide by 2 on both sides, which tells me x is negative 1. PS, does it make sense? Now please, if I ask you, does it make sense? I'm not saying, is my calculations correct? Can you follow me? I'm asking, on the sketch, does negative 1 make sense on the sketch? Yes, it does, because t lies on the negative side. So I've got my spidey sense tingling that it does make sense, okay? But I'm not done, because they're asking me for a set of coordinates. But I can go and substitute the negative 1 in so long in my coordinates. So let's find the y value. So I'm going to go to fx, and I'm going to make my x negative 1. Therefore, my y value is negative 3, and hence I've answered the question. So when I look now at 7.5, is a beautiful question. 7.5 is a doozy. It's worth, if I'm not mistaken, 6 marks. I don't have it on the sketch here, but if I remember, it's 6 marks. Why is it so much? Because there's actually a lot of algebra involved in here. So let's interpret the question before we go too far, okay? If I look at this, they say I've got a straight line for gx. So gx is some kind of straight line with an equation mx plus c, y equal to mx plus c. But they tell me as well the word parallel to AE. So I know the gradient of those two lines must be now the same. This tells me that the gradient of AE must be the gradient of KR. Now in blue at the top, you will see that I highlighted the word cuts F, because that on the official memo, they actually do an intersection between Gx and the graph fx. But I don't want to follow that procedure, okay? I don't want to do it that way. I want to use gradients, because that is for me so much simpler. Because if I look at this, I have the gradient of AE. All I need now is a gradient for KR. I know that K is the set of coordinates negative 3, negative 9. I know that R lies on fx. How do I know that, sir? Because it says that's where the line cuts F. So what I'm going to do is, instead of writing fx as the y value, I'm going to actually substitute the equation of fx into the coordinate. And this is going to give me the x value is just x, but the y value is the function of fx's equation. So in other words, just want to do it, fx is that x squared minus 2x minus 24. I know it's maybe a bit weird. You maybe haven't done it this way before, but for me this is so simple, because all I'm going to do now is actually get the gradient between k and r using these equations. So I'm going to first of all start by saying the left-hand side is a quarter, because that's the gradient of AE. But on the right-hand side, I've got the gradient, I need the gradient of KR. So I'm going to substitute literally y2, which is x squared minus 2x minus 24, minus the negative 9. And I'm going to do the same with the x values. X minus negative 3. And now I've got I want to say basic, but now I've got a quadratic equation that I need to solve. So I'm going to do what you guys love to do, which is cross multiply. So in other words, I'm left with x plus 3, and on the right hand side, 4 times that top, the numerator. Almost got my numerators and denominators mixed up, but the numerator. I've just got to solve x now. So I'm going to simplify, I'm going to transpose, I'm multiplying out brackets, I'm putting it in standard form. Now I have to factorize, and this is a difficult factorization. If it is too complicated, do not feel ashamed of using the quadratic formula. My students use all the techniques that is available. Use all the tools that are available for you. Now, I'm not done yet because I still need to find the x values. So finding the x values, I've got 2 options. 21 over 4 and negative 3. Which one of the x values is going to be the x coordinate of R? Well, look at K. K is negative 3. Yes, it should be because it says that's where the 2 graphs intersect. So automatically, I actually know that this is where the 2 graphs are going to intersect. So, in other words, x can't be negative 3. Therefore, x is 21 over 4. And the beautiful thing for me, ladies and gentlemen, is as I'm looking at this, as I am looking at what I wrote down, I realize I could have made this sum 20 times easier. Let me show you how. So let's first of all erase just this what's on the board now and make life easier, okay? And this I love about maths because there's a lot of different alternatives with this. So if I look at this and I just look at the right-hand side, I'm going to try and just simplify that as far as I possibly can, okay? So if I add the top, I actually sit with a polynomial, a trinomial, which I can factorize. And the beautiful thing is, look what happens. That x plus 3's, both of them actually divide away. But an interesting thing is, and this is something you have to remember whenever you're working with a fraction, there's always a restriction. This x plus 3 may not be 0. So x may not be negative 3. Just a little side note, which leaves me with a quarter being x minus 5. If I now transpose that 5 and I add it, I get exactly the same answer. Oh my goodness, this is beautiful. This is so gorgeous. I love mathematics. Ladies and gentlemen, I hope you enjoyed this video with me. I hope that you watched it and that you can learn from it. So just to backtrack a few things, before you answer the question, analyze. Every line, use your toolbox, use all your knowledge. Then look out for key words, y-intercepts, x-intercepts, turning points, range, minimums, tangents. there's a lot of small little words you need to look out for. Perpendicularity, parallel. Those words mean something. So you've got to learn to kind of not just browse over it and just read. I want you to interpret. I want you, as you let the bell go off in your head, which says, this means something for me. Then you write down what it means. And if you don't know what it means, you still have a bit of time before the exam to sharpen that sword. So this is Mr. VG. I loved having this time with you. I'm signing out and imploring with you, work hard, but keep yourself safe. Look after yourself and have a beautiful rest of your day. Keep well. Cheers.